In the last part of session 9.3, I would like to talk about quartz, which is also a solid with giant covalent structure. Quartz actually composed mainly of a covalent compound we call silicon dioxide, SiO2. If you refer to the structure of silicon dioxide, you can see the structure of silicon dioxide looks similar to that of diamond. So that means if we consider the properties of silicon dioxide, quartz, it has similar properties to those of diamond. Additionally, in the public exam, you may be asked, for example, the number of oxygen atoms or number of silicon atoms bonding to each silicon atom and each oxygen atom respectively. Now, let us summarize the general properties of giant covalent structure. First, all of them should be solids because, as I mentioned before, in the giant covalent structure, the atoms bond together with strong covalent bonds. So that's why we have to supply heat energy to break a large number of strong covalent bonds to melt the solid. And that's why the solids of giant covalent structure should have high melting points. So this is the picture of the melting process for your reference. Second, the substances with giant covalent structures are hard. The same reason, strong covalent bonds, and the atoms cannot slide over one another. The third one, they are insoluble in any solvent because it's unlike the giant ionic substance, in which the oppositely charged ions can be attracted by water molecules when they dissolve. Similarly, substances with giant covalent structures are unlike simple molecular substance because in simple molecular substance, they dissolve in long-aqueous solvents such as thinner, since the molecules in simple molecular structures may attract the molecules in the long-aqueous solvent, and that's why they dissolve. But in case of giant covalent structures, as the composing unit are numerous atoms, which are bonding with each other with strong covalent bonds. So that's why if we want to dissolve the substance of giant covalent structure, we have to break the strong covalent bonds and making the separate atoms attract by the solvent particles. But as he mentioned here, it is very difficult to separate them, and that's why the substance of giant covalent structures are insoluble in any solvent. Finally, in the substance of giant covalent structures, as the atoms bonding with each other with strong covalent bonds and the outermost shell electrons are used up in covalent bonds, and they are held firmly by the nucleus. So that's why the scientists find that they do not contain the localized electrons in the structure. So that's why the substance with giant covalent structure, except graphite, are long conductors of electricity. Now, after you learn the last part about giant covalent structure, please try to do the class practice 9.2 and we will check the answer later.